So we're just doing questions from the homework today, but from the ultimate review, that's this one here. I like number one, I like number one, I like number one. Number one is a nice question. I'll even highlight them a little bit. Yay! Number two is good. I really, really like number three. So number three is an Atwood-ish type machine, except what am I asking you to find? Not the acceleration. That's also Physics 11. What am I asking you to find in number three? The mass. There's going to be a question where I give you two masses, and I'm either going to tell you the acceleration or the tension, and you're going to have to find a missing mass. So I like number three. Number four, don't circle. Number four is talking about Newton's laws. You should know them. I'm not going to ask you a question that specifically requires you to know that Newton's first is the one that talks about objects at rest, the one that says if the net force is zero, you can't be accelerating. And that Newton's second is F equals ma. And that Newton's third is forces come in pairs. I'm not going to ask you to know that, but you're going to be required to know them to do your free body diagrams and things, okay? I like number six. Number six is a nice example of, so the new Physics 12 was with an incline, but I already told you, I got to be honest, the inclines to me are too simple. I'll ask you to do something with the acceleration. In this case, they're asking you to find D. No, they're not. You're going to spend most of your time finding the acceleration by a good free body diagram. 7 is good. Finding a missing mass. Although even number 7 and number 3 are a tiny bit too easy because it's frictionless, I would probably also give you some friction in there just for giggles. Eight is good, finding a mu. Number 9, I like number 9. What is number 9? A purely algebraic question. I guarantee I'm going to give you a multiple choice, purely algebraic question with no numbers. Now, to solve it, you can always make up numbers that are nice ones, crunch those numbers, get an answer, and then compare your answer to the 4 algebraic ones that you see. Oh, I started out with 5, I got an answer of 10. I think the answer is twice as big. Which of these answers is the algebraic version of twice as big, or whatever? Or you can do them algebraically. I love number 10. Lawnmower question. There's going to be a lawnmower question. You're either going to be pulling up at an angle or pushing down at an angle. In other words, you're either going to be making the normal force bigger or smaller, but not mg. This would also be a nice question if I was asking you about to draw or identify a free body diagram, because the key component, the key idea here is that the normal force is not the same size as mg. So if you drew the free body diagram and out of habit you went something like mg and normal force and they were the same length, I'd absolutely take marks off. Sure, 12, finding a missing mass. Now, in number 12, they give you tension, and then they say find the acceleration, use that to find mass too. I think in number 3 and the other one, I think there they gave you the acceleration, you would find tension and use that to find mass too. Both interchangeable as far as I'm concerned. I love number 13. $14 is good. What you're going to notice, if it's just one mass on an incline, the notion of saying find the acceleration, I'm already arguing is boring. I'll either give you the acceleration, go backwards, find mu, or I'll ask you to do something with the acceleration. Okay. 15, there is going to be a question either as a written or as a multiple choice where I ask you to either draw a free body diagram for marks, or I give you 4 to pick from, and I say pick the correct free body diagram as a multiple choice question. So I don't know yet whether it'll show up as a written or as a multiple choice, but it absolutely, there'll be one on there, and I'll even be more blatant. It'll almost certainly be a free body diagram that has some angles in it, so it's either going to be a lawnmower or a ramp. 16 is good, finding a missing mass. 17, absolutely, I like number 17, like number 17, like number 17. Although, I might even... 17 is okay. I would have no problem, Bryce, instead of having mass 2 have wheels, I would have no problem also having friction there. instead of making it frictionless. It adds one more expression, one more thing in your equation, and your winner minus loser. Meh. 18 is good. This is a normal force that isn't mg. 19 is an Atwood machine where you know both masses. To me, that's too easy. Like, do it, please, but that's Physics 11. In fact, those of you that had me last year, I gave you this question on the Physics 11 forces test, and most kids whomped on it. You know what? You can nuke 22. I'm not going to do much graphing this year. Something had to go, and I'm cutting some of that out. 23 is okay. Ooh, but absolutely 24. Although, again, Connor, I almost find this too easy because what's underneath this 18-kilogram cart begins letter W and rhymes with eels. No friction. You know what? If I give you that picture, I'm going to put a friction component there. I'll put a mu there. Why not? By the way, this is actually in some ways a nice easy diagram in that you absolutely know which way this thing is going to accelerate. Clearly it has to accelerate down and right. There's no way that it can possibly start going up and left. So some of you were asking me during the flexor earlier, how do I know which way it's accelerating? You can calculate it. I showed you a way, but I think this one's a little more intuitive. I think it's down and right. Sure, 26, although again, a little too easy, but okay. 28, drawing a good free body diagram. .32, good free body diagram. Ooh, elevator question. There's absolutely going to be an elevator. You know what? It'll be a multiple choice question as an elevator question on your test, so 33 is good. 34 is good. We got an applied force. In number 34, there are two words that are the key to solving this question. What are the two words that are the key to solving this question? 34. There are two words. I'll even give you a hint. It's the last two words of the question. Come on, people, help me out here. Constant speed. Because what does that mean? A is. So when you go winner minus loser, it'll be winner minus loser equals, which makes the equation way easier. I could also, if I wanted to make it a little bit harder, instead of saying what's the force necessary to push it up at a constant speed, I could say how big does F have to be if we're accelerating up at 2.2 meters per second squared? I don't think I will. Might, nah. Now here's the weird thing. The scholarship questions, some of these are fair game. Number one, not really, although if you do number one and you look at my solution key, you'll see it's all Physics 11, much like that number 9 from, I think, lesson 5, which was the Atwood machine, one dropping, one going up. A lot of you have asked me about that, and when I showed you my solution, it was all Physics 11. It's just too many steps. So number one, I'm going to say every part of it is fair game. Too many steps for one written question. But I'm telling you, question number 2, I have no reason why that's a scholarship question. Do they give you mu? Read carefully. Do they give you the coefficient of friction? Yeah, okay. Free body diagram, one's on a ramp. One's not on a ramp. That actually, I mean, the right-hand mass, lovely free body diagram. You'll have M2G down, tension up. Find the acceleration. I've given you stuff this tough in your homework. So absolutely 36 is fair game. Worth doing. Absolutely, that was 36? That's 38. Okay. Don't know what happened to 37. I must have nuked it. 38A, totally fair game. Absolutely. 38B is also fair game. 38A and 38B in one question, too long. But 38B, it says, if you move 0.15 kilograms from this box to that box, well, that makes this one 0.3 kilograms, and that makes this one 0.5 kilograms. And now we're back to an Atwood machine on a ramp. Oh, but you had to find the coefficient of friction in part A first. I would never, that's too much work. But so I'll circle each of these as kind of a separate, each one is fair game, but altogether too much. But again, I got to be honest, like 39, totally fine. 39, A and B, to me, totally fine in one question. That I would say you can handle. Because once you find the acceleration, finding the tension, you'd use this math, 2 lines, and this math's 2 lines, and you're done, I think. So this is a different one. Some of those scholarship ones are fair game. 40, you can nuke completely. I haven't done my lesson yet on graphing tricks, which is why I'm skipping the graphing ones right now. In the next unit, I will probably do a lesson on, here are tricks for graphs. Okay? Pause the video. So, the take-home quiz you all have looks like this. Absolutely something like number 1 will be on your test. What do I mean by that? If I give you one mass on an angle, on an incline, I'm not just going to say find the acceleration. I'll ask you to do something with it. In this case, what's number 1 asking you to find? Justin, what's number 1 asking you to find? See, now you're back. I know my audience. Justin, what's number 1 asking me to find? You know what you're going to spend most of your time finding? Not time. I think you're going to spend most of your time finding the acceleration by going winner minus loser. But once you have the acceleration, then you'll be able to use Unit 1 stuff. Okay? Turn the page. Number 2, Atwood machine, find the tension in the rope, and then find mass 2. Number 3, here is an example of a using, number 3, follow along please. Number 3, here is an example of a, by the way, that's probably why you didn't know the test was on Thursday there, Chief. Okay. Here is an example of a using principles of physics right to explain question. You can probably answer this with a good free body diagram, but here's what it says. So a student of mass big M places a bathroom scale on a skateboard. Whenever I'm talking about a bathroom scale, what's that physics code for? Which force am I really talking about here? So in your free body diagrams, make sure you're focusing on your normal force. He then rolls forward on level ground while standing on the scale, which is still on top of the skateboard. So put a scale on a skateboard, roll forward. What will the scale read? Less than M, more than M, or M? That's question number 1. It's a quiz. Don't blurt out answers, even if you're wrong. Or maybe you're right. Who knows? Then, part B says this. Now the student rolls down a skateboard ramp at an angle while still standing on the bathroom scale. The angle is inclined at an angle theta. What will the scale read now? More than M, less than M, or M? Using principles of physics right to explain. You can do a free body diagram. You can do a lovely algebraic proof. I would. But you could also, if you want to, Alec, make up reasonable numbers and crunch the numbers and use that to pick the right answer. In other words, you could, instead of angle theta, you could make it an actual angle. Instead of mystery mass M, you could make it an actual M in kilograms. But I'll probably try and do this algebraically with the free body diagram because I'm a nerd. But I will always allow you to do reasonable numbers. There will be, on your test, some kind of a using principles of physics right to explain question. A lot of the stuff that I've been throwing at you where I've opened classes up with those conceptual questions, I'm trying to give you some tools on how you can answer that. Go to an extreme value. What if theta is 90 degrees? What if theta is 0 degrees? All those tricks of the trade. Number 4. There's a small problem with number 4. Not big, but I'm just going to warn you. So number 4, I like number 4. Atwood machine with an angle. That's physics 12. Number 1 says find the acceleration. B says find the tension. And initially there's no friction. Then, once you've done that, C says what would the minimum mu coefficient of friction need to be between M2 and the ramp to keep the entire system stationary, to keep the entire system at rest. I made up some bad numbers. You're going to get a mu, and I'm going to tell you right now, your mu is a tiny bit bigger than 1, which is a little weird because usually our mu's have been decimals. What does a mu bigger than 1 mean? Honestly, you'd need to glue it down. What has a coefficient of friction bigger than 1? Glue, because glue can hold its own mass and more than its own mass. But we're not going to dive down into that because what I've told you is also technically wrong because glue is not a friction. Anyways, it's a good way to think about it as an analogy, as a good model. But for now, I'm going to tell you when you do when you do part C, you're going to get like 1.0 something, 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 something. I've changed the numbers. If you flunk my course, next year you'll get a much more realistic coefficient of friction. Turn the page. Josh, what's number 5 asking me to find? Hey, Josh, what's mu? I don't know. What's mu with you? I think to find mu, you're going to start to go winner minus loser, a good Freebody diagram. Partway through, you're going to go, wait a minute. I need something else. But there's other information the question gave you, the fact that I gave you a time and the V final and the V initial. You can probably find that something else as well. And then number 6. I like number 6, I like number 6, I like number 6. Here is your example of a lawnmower question. I'm going to ask you to draw a free body diagram. Please draw the free body diagram in the white space here. You can also label your picture, but I will not mark this. I will mark whatever you draw in this white space here. I strongly encourage you to do this in the order that I've listed. Pierce, what's B asking me to find? Friction is what times what? What's mu in this question? Pierce, what's D asking me to find? So there has to be another way to find friction. I'm going to tell you how you can. You can figure out friction not from going mu times the normal force, but from going winner minus loser and getting the friction force by itself. That's why I made that part B. Once you have part B, you'll also be able to find part C, a normal force, and then you'll be able to find mu by using friction equals mu times the normal force. Every year I have some kids that make up a mu, they do all sorts of weird stuff. So the class is yours to work on the take-home quiz and to ask me any questions that you want. Taylor, did it meet your expectations? You got all your hints and your help that you were wondering about? See?